Section 300.22c of the 2002 National Electrical Code addresses wiring in ducts, plenums, and other air handling spaces. This section is critical for ensuring the safe installation of electrical components in areas where air circulates for heating, ventilation, or air conditioning. The primary concern is to prevent the spread of fire and toxic fumes through the ventilation system in the event of an electrical fault. Section 300.22c is divided into subsections that outline specific requirements for different types of air handling spaces and wiring methods. These requirements vary depending on the type of space and the materials used for wiring. In general, the code mandates the use of wiring methods with low smoke and flame characteristics in air handling spaces. This reduces the risk of fire spreading and minimizes the release of harmful substances into the air. One of the key aspects of Section 300.22c is the definition of different types of air handling spaces. These spaces include ducts specifically designed for transporting air, plenums used for distributing air, and other spaces used for environmental air. The requirements for wiring in these spaces differ based on their specific characteristics and the potential for fire and smoke spread. For example, ducts used for exhaust air may have different requirements than plenums used for supply air. The code also addresses the types of wiring methods that are permitted in air handling spaces. In general, only wiring methods that are specifically listed and labeled for use in these spaces are allowed. These wiring methods typically have low smoke and flame characteristics and are designed to prevent the spread of fire. Examples of permitted wiring methods include plenum-rated cables, metal conduit, and certain types of flexible metal conduit. The use of non-metallic conduit or cables is typically prohibited in air handling spaces due to their potential to contribute to fire and smoke spread. Section 300.22c also includes requirements for the support and securing of wiring in air handling spaces. Wiring must be properly supported and secured to prevent it from sagging or coming into contact with other objects. This helps to ensure that the wiring remains in place and does not pose a fire hazard. The supports and securing methods used must also be suitable for the environment in which they are installed. In addition to the general requirements outlined above, Section 300.22c also includes specific requirements for certain types of equipment and installations. For example, there are specific requirements for the installation of lighting fixtures, motors, and other electrical equipment in air handling spaces. These requirements are designed to ensure that the equipment is installed safely and does not pose a fire hazard. It is important to note that Section 300.22c is a complex and detailed code section. It is essential to consult the actual code language and any applicable interpretations or amendments before making any decisions about wiring in air handling spaces. Failure to comply with the requirements of Section 300.22c can result in serious safety hazards and code violations. The proper application of Section 300.22c requires a thorough understanding of the definitions, requirements, and exceptions outlined in the code. It is also important to consider the specific characteristics of the air handling space and the equipment being installed. By following the requirements of Section 300.22c, it is possible to ensure the safe and reliable operation of electrical systems in air handling spaces. Remember that local codes and regulations may have additional requirements that must be followed. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Section 300.22c further delineates specific applications and permissible materials. For instance, it often restricts the use of flexible metal conduit, also known as F&C, in air handling spaces unless it meets specific requirements for low smoke and flame propagation. Regular F&C might not be suitable unless specifically listed and labeled for such use. Instead, electrical metallic tubing, also known as EMT, or rigid metal conduit, also known as RMC, are often preferred due to their fire-resistant properties. When installing wiring within a manufactured duct, The NEC generally requires the use of wiring methods suitable for the environment and installed in accordance with the duct manufacturer's instructions. This means carefully reviewing the duct manufacturer's specifications and selecting wiring methods that are approved for direct contact with the duct material. If the duct is exposed to moisture, the wiring must be rated for wet locations. Furthermore, all wiring must be securely fastened to the duct to prevent movement and potential damage. In plenums, which are often concealed spaces above ceilings used for air distribution, the NEC mandates the use of plenum-rated cables, which are specifically designed to minimize smoke and flame spread in the event of a fire. These cables are tested and listed to meet rigorous fire safety standards, ensuring they will not contribute significantly to the spread of fire or release harmful toxins into the air. Regular cables are generally prohibited in plenums because they can quickly ignite and produce large amounts of smoke, posing a significant hazard to building occupants. In addition to cable types, the NEC also addresses the installation of electrical equipment in air handling spaces. For example, lighting fixtures installed in plenums must be designed to prevent the escape of sparks or hot metal in the event of a lamp failure. The fixtures must also be securely mounted to prevent them from falling and causing damage. Motors and other electrical equipment must be similarly protected to minimize the risk of fire or electrical shock. The NEC also provides guidelines for the installation of fire dampers in air ducts. Fire dampers are designed to automatically close in the event of a fire, preventing the spread of flames and smoke through the ductwork. The NEC requires that fire dampers be installed in accordance with their listing and labeling, and that they be accessible for inspection and maintenance. It is crucial to understand that the requirements of Section 300.22c are not static. They are regularly updated and revised to reflect new technologies, materials, and safety concerns. Therefore, it is essential to stay current with the latest edition of the NEC and any local amendments or interpretations. Consulting with a qualified electrical inspector or engineer is always recommended to ensure compliance with all applicable codes and regulations. A thorough understanding of Section 300.22c is essential for anyone involved in the design, installation, or maintenance of electrical systems in buildings. By following the requirements of this section, it is possible to significantly reduce the risk of fire and other hazards associated with electrical wiring in air handling spaces. This ultimately protects building occupants and helps to ensure the safe and reliable operation of electrical systems. In summary, Section 300.22c is a critical component of the NEC that addresses the safe installation of electrical wiring in air handling spaces. It mandates the use of appropriate wiring methods, equipment, and installation practices to minimize the risk of fire and smoke spread. By adhering to the requirements of this section, it is possible to create safer and more reliable electrical systems in buildings. When examining Section 300.22c, one must consider its application in various scenarios. For instance, in a commercial building, the plenum space above a suspended ceiling is often used as an air handling space. In this case, any wiring installed in this plenum must comply with the requirements of Section 300.22c. This means using plenum-rated cables, ensuring proper support and securing of the wiring, and avoiding the use of materials that could contribute to fire or smoke spread. Similarly, in a residential building, the space around a furnace or air conditioner may be considered an air handling space. Wiring in this area must also comply with Section 300.22c. This may involve using metal conduit or other approved wiring methods to protect the wiring from physical damage and to prevent the spread of fire. In addition to the type of space, the specific application also affects the requirements of Section 300.22c. For example, the requirements for wiring used to power a lighting fixture in an air handling space may differ from the requirements for wiring used to power a motor. Lighting fixtures must be designed to prevent the escape of sparks or hot metal, while motors must be protected from overheating. The NEC also addresses the use of abandoned cables in air handling spaces. Abandoned cables are cables that are no longer in use but remain in place within the air handling space. The NEC requires that abandoned cables be removed to prevent them from contributing to fire or smoke spread. This is because abandoned cables can accumulate dust and debris, which can increase their flammability. Removing abandoned cables also makes it easier to identify and maintain active wiring. Another important consideration is the proper grounding of electrical equipment in air handling spaces. Grounding is essential for preventing electrical shock and ensuring the safe operation of electrical systems. The NEC requires that all electrical equipment in air handling spaces be properly grounded in accordance with the applicable requirements. This typically involves connecting the equipment to a grounding electrode system, such as a grounding rod or a metal water pipe. The grounding conductor must be sized appropriately for the equipment and must be securely connected to the equipment and the grounding electrode system. In addition to grounding, overcurrent protection is also critical for preventing electrical hazards in air handling spaces. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity in the event of an overload or short circuit. The NEC requires that all electrical circuits in air handling spaces be protected by overcurrent protection devices that are properly sized for the circuit. The overcurrent protection devices must be installed in readily accessible locations and must be clearly labeled. It is also important to ensure that the overcurrent protection devices are properly maintained and tested on a regular basis. This helps to ensure that they will function properly in the event of an electrical fault. The NEC also provides guidance on the use of surge protection devices in air handling spaces. Surge protection devices are designed to protect electrical equipment from voltage surges, which can damage or destroy sensitive electronic components. The NEC recommends the use of surge protection devices in air handling spaces where sensitive electronic equipment is installed. The surge protection devices must be installed in accordance with the manufacturer's instructions and must be properly grounded. In addition to the specific requirements for wiring and equipment, the NEC also includes general requirements for the installation of electrical systems in air handling spaces. These requirements address issues such as workmanship, access, and labeling. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that the wiring must be properly installed, supported, and secured. The connections must be tight and clean, and the equipment must be installed according to the manufacturer's instructions. The NEC also requires that all electrical equipment in air handling spaces be readily accessible for inspection and maintenance. This means that there must be sufficient space around the equipment to allow for safe and easy access. The equipment must also be located in a well-lit area so that it can be easily inspected. Finally, the NEC requires that all electrical equipment in air handling spaces be clearly labeled. This includes labeling the equipment with its voltage, amperage, and other relevant information. The labeling must be durable and easily readable. Proper labeling helps to ensure that electrical workers can safely and efficiently maintain the equipment. In conclusion, Section 300.22c is a comprehensive code section that addresses the safe installation of electrical systems in air handling spaces. It covers a wide range of issues, including wiring methods, equipment, grounding, overcurrent protection, and surge protection. By following the requirements of this section, it is possible to significantly reduce the risk of electrical hazards in air handling spaces and to ensure the safe and reliable operation of electrical systems. It is important to remember that the NEC is a complex and constantly evolving document. It is essential to stay current with the latest edition of the NEC and to consult with a qualified electrical inspector or engineer when making decisions about electrical installations in air handling spaces. By doing so, you can help to ensure the safety of building occupants and the integrity of electrical systems.